works out of the proton. If you try, here is a proton. It consists of 3 quarks. But if you try to pull them out, a very strong force field develops because of that, the weird properties of the quantum vacuum, and you can never get them out. Okay. Let's go to the next field, cosmology. Here within, over just 1 century, we have learned that our sun is part of 100 billion stars in the galaxy. And whereas 100 years ago the galaxy was the universe, we now know that the galaxy is only one of 100 billion galaxies in a universe that is expanding at a more or less constant rate. And we have learned that all of that emerged from a hot, big bang, a very small condensed region, 13.7 billion years ago. We can look back and take a picture of the universe 13.5 billion years ago. This just illustrates the expanding scope of our knowledge of the universe, from our planet to the solar system, each time a factor of 1 billion to the galaxies, to the universe as a whole. Notice, if you look at the universe as a whole, that part that we can see, it is very homogeneous, as it was 13.5 billion years ago. This is a picture of the radiation that was emitted 13.5 billion years ago from the hot gas left over from the Big Bang and is reaching us 13.5 billion years later. We have in fact mapped out the history of the universe from close to the beginning until today, and understand in great detail how it evolved, how the little fluctuations in that hot gas way back then clumped together and produced galaxies and stars and planets. But we still find one enormous mystery, the Big Bang, which started the whole thing going. And there, we still do not understand what went on and are pushed further. Biology. Here, this is the youngest of the sciences, in a sense, and one where the serious advances only began in the 19th century. But how far have we come so fast? Over the last 150 years, we have learned that life emerged over 3 billion years ago and evolved by mutation and natural selection. We located and deciphered the genetic code and outlined the basic mechanism of living cells, discovered the cause of disease. And finally, we have localized the source of consciousness and emotion in the brain and have started to explore its mysteries. It began with Darwin, who had a wonderful and, as it has turned out, enormously successful theory in which he explained the changes and evolution of life as proceeding via natural selection, and demonstrated by meticulous observation how that can produce all the variations of living matter. By now we have mapped out an incredible history of life on our planet. 3 billion year history with an incredible variety of different species. We, of course, are a very late comer in this history, have only appeared very recently. But one of the most important lessons we've learned, not just for science, but for human culture and politics is that all humans have a very recent common ancestor and a common origin. Life has been on the planet for 3 billion years, Homo sapiens for more than 1 million years. But all of us had a common mother and a common father, different. They weren't necessarily married or even lived together. But there was a bottleneck in our evolution. We all came from a common source only about 150,000 years ago from somewhere in Africa. And we are beginning to map out how this single human family has spread over the world in this very short time. This lesson that makes all racial bigotry silly and obsolete hasn't, I think, totally sunk in around the world. We're all related. It is silly to talk of one's recent relatives. We're all very closely related. In the last 50 years, we have made extraordinary advances in biology, as we did in physics, in understanding the microscopic structure of life, how the cells work. These, by the way, are stem cells. The genetic code is embodied in the nucleus of each cell and contains the information necessary, the blueprint for all the functions of all the different cells in our body. It does so by producing RNA that creates proteins that do the work of the cell. And we're now ready to truly construct a quantitative understanding of the function of life based on this microscopic structure. For the benefit of mankind, we learned that disease is caused by bacteria like this, viruses, both of which we know how to control to some extent, and by genetic mistakes, which we are learning how to control. And finally, we have discovered that the locus of thought and emotion, what makes us human, is in the brain. And the brain is just a jungle of 100 billion interconnected neurons, and we are beginning to unravel, but just beginning, the microscopic structure of how this collection network of neurons work. Eventually, we will understand the origins of thought and emotion. So, this has given us enormous control of nature. Basic science inevitably leads to greater control over nature and unpredictable new tools. It cannot, what use basic science will be is not something that can ever be predicted. But it always happens. And the new technology that science has produced has been of immense benefit to humankind, but also presents grave dangers. Of course, science had its first enormous impact on human civilization by underlying the Industrial Revolution with a steam engine, electricity, and magnetism, and now the application of quantum mechanics to modern technology, which has given us things like instruments of communication and calculation beyond anyone's imagination just 50 years ago. But along with all of these benefits, including the benefits of medicine, which have produced drugs, imaging techniques, and many other advances that have led to the doubling of the lifespan of humans in the last 200 years. So today, each of us has 2 lives because of the advances that science has made possible. But in addition, science has led to, through all of this power over nature, to powerful and awful weapons that have given us for the first time the ability to destroy the species. And now, perhaps even greater threats to the health of our beautiful planet. Science has doubled the lifespan of humans, which is great, and has eliminated disease, or many diseases, and that's wonderful. But as a consequence, the human population has taken off like a bomb. If you extrapolate this curve, you discover this curve fit very well till the year 2000. This curve becomes infinite in 7 years from now. Now, people think that's not going to happen, and rather we will level off with a world population of somewhere between 9 and 15 billion people. But that's a lot of people for our small planet compared to the 1 million or less that we've had for most of our existence. And those people are demanding more and more and more. So the global energy conservation is tracking, in fact, is expanding more rapidly than the population growth. And you'll notice that most of this consumption of energy is using fossil fuels, oil, coal, and gas. And as the whole world is beginning to realize, this has dramatic consequences on the planet, especially on the temperature of the planet from CO2 emissions. As this is from the IPCC report, this is the UN committee that won the Nobel Peace Prize this year for their work on global warming, and tracks the rise in temperature, which you see just takes off in the year 2000. These are their projections for the next 100 years with various assumptions. Assumptions as to how we, as a world, respond to this crisis. But the numbers are frightening. These might seem like small numbers. These are the increase of air temperature at the Arctic, 2 degrees, 4 degrees, up to 8 degrees by the end of the century. And what causes that, of course, are carbon emissions. If you track the temperature change, you see that it tracks very well the amount of CO2 that we are putting into the atmosphere. There is by now